From the CUBE studios in Palo Alto and Boston, bringing you data-driven insights from the CUBE and ETR. This is Breaking Analysis with Dave Vellante.
We are witnessing the creation of a new market. It's unfolding right before our eyes. Inside of a decade, a $1 trillion plus data center business is being transformed, powered by what we're calling extreme parallel processing to support AI. This new capability is replacing general purpose computing at a very rapid pace and is going to have impacts up and down the technology stack. Of course, semiconductors are the enabling catalyst of this transition, but there is so much more to the story. NVIDIA is leading the charge, and despite competitive aspirations, we believe NVIDIA has a 10 to 20 year horizon to drive this new wave of what the company calls accelerated computing. Its advantages transcend silicon design and comprise the integration of hardware and software, a systems approach, a rapidly evolving and purpose-built software stack, and an ecosystem composed of virtually every tech company on the planet. Hello and welcome to this week's theCUBE Research Insights powered by ETR. In this breaking analysis, David Floyer and I will share our views on the changes to the technology landscape and the growing competitive environment. And we're going to unpack NVIDIA's Moat. We're going to drill into its software architecture, connect the pieces together, and put forth a forecast of what it means for data center spending generally and extreme parallel processing specifically. We'll also take a quick look at some ETR data and discuss the coming AI PC trend. David, welcome back to Breaking Analysis. We took a little break over the holidays. This is number 261, so we're on a good pace. Good to see you again.
It's great to be back on Breaking Analysis. The thing that is of great interest to me is that this is a complete new market. It's a $1 trillion plus market. And it's just exciting, and it's incredibly important to every programmer, every executive, and every vendor. So I'm very pleased to be here.
Great, all right, let's dive right in and look at how every aspect of the technology stack is going to change as a result of what we're referring to as extreme parallel processing, this trend EPP. The key to this slide is every part of the stack as we know it is becoming optimized for AI, meaning that each layer is going to learn how to exploit this new form of computing, where of course GPUs are at the heart of the matter. So let's start at the bottom left with compute. General purpose compute, which is dominated for so long by x86, is being replaced very rapidly by extreme parallel processing. GPUs are at the heart of this transformation, and we've talked a lot about distributed clustered systems that increasingly are leveraging high bandwidth memory, HBM. Now, while storage is not necessarily the most critical part of the AI revolution, data is, and a very important part, and the data needs to be accessible. We're talking here about distributed file systems, object storage, petabyte scale, smarts or intelligence around data location to enable what we're referring to as anticipatory staging, being able to identify what is going to be needed next and staging that so that it is proximate to the request. And this is going to drive higher performance. And of course, we're going to use NVMe, SSDs, and all-flash arrays, which we've talked about for years. And these trends are the ones that we see in storage, but networking is where there's so much action taking place with ultra high speeds, ultra low latency. Networks are going to be needed to support parallel processing in a big way. We're seeing it happening. It started with InfiniBand. Ultra Ethernet is on the horizon and is going to scale. All the hyperscalers are leaning into Ethernet. Even NVIDIA is leaning in. And so the cloud and mobile traffic, when we witnessed that movement, we saw traffic move from the north-south trajectory to an east-west focus. And today we're seeing traffic in all directions with these increasingly distributed systems. So let's take a beat right here and get David's thoughts on the left side of this graphic. David, what would you add?
Well, I'd like to focus in on the compute side. For all of us involved with multiprocessors and have been for many years, it's always been difficult to get multiple processors to be working on a particular application altogether. So it's very difficult to get 20 working together. Getting to 100 is almost impossible. The challenge of this new environment is that we have much lower cost, smaller processors doing little things, but we have to spread that load over a large number of those processes inside a GPU, and then very large numbers of GPUs. So that is the challenge in compute, and that's the breakthrough that has happened to allow that capability.
Now, just to clarify, people might hear what you just said and say, wait a minute, these GPUs are super expensive. You said they're very low cost. So square that circle.
The cost per unit of compute is very much cheaper. I mean, yes, the GPU is expensive as a whole, but when you look at the cost per unit of compute, it is much lower.
Got it. Okay, so that's the hardware side of the equation. Let's come back to the same graphic and unpack the right side, which is the software stack. And we're going to start with OS tools and middleware here in the bottom right, Sidle operating systems. And here we're talking about libraries, compilers, and things of that nature that are designed to exploit GPUs and this notion of parallel computing. So this it really is an enabling layer for new types of applications to be built. Now, as we move up the stack to the data layer, which is really important, we see the critical need, and we've talked about this a lot, a need to harmonize that data so that things like agents can understand it, unified metadata models, and then connections to both analytic and operational systems to operate in real time versus today's, what essentially is an asynchronous historical system of truth on the analytic side and a series of silos on the operational side, whether it's CRM or HCM or ERP. Now, if you move further up the stack to applications, we see intelligence functionality being built into both horizontal applications, like those that I mentioned, human capital management, ERP, supply chain, CRM, and also vertical systems that on both sides are understanding human language and natural language processing. These applications will be able to learn from the reasoning. These systems be able to learn from the reasoning traces of humans and act as systems of agency on behalf of humans and begin to represent the real world digitally in real time. David, how do you see the software stack changing as a result of AI and even some of these new applications like robotics, which are super exciting? We heard a lot from Jensen at CES this past week on that topic.
Absolutely. I'd like to focus in on actually one area which is really difficult, which is the operating system area, because we have the complexity within the operating system of being the necessity of sharing it between lots of processors, CPUs, lots of GPUs, lots of other capabilities in the network of compute, and the functionality of that OS has to be improved by many orders of magnitude, and that's a crucial part of being able to take advantage of this highly extreme parallel environment.
Okay, great. Now, of course, at the heart of these changes is silicon, generally, and GPU specifically. Here's a graphic of the 5-year performance, stock performance of key players in silicon. You can see the green shaded area, which starts in late 2022 with ChatGPT, kind of the AI zone. And you can see NVIDIA broke away from the pack. We all know it's now the most valuable company in the world, $3+ trillion valuation. Now, we said in 2023 that Broadcom and NVIDIA were the two best AI plays in silicon, along with, of course, the hyperscalers. And the market finally woke up to that. You can see that this year, Broadcom really started to tick up and had quite a strong past 12 months. Now, Broadcom doesn't compete head on with NVIDIA. And we think that's a feature, not a bug. At the same time, they really provide critical infrastructure to Google and Meta and ByteDance for their custom silicon, which does, in essence, in a way, compete, and we'll talk about that, with NVIDIA as potentially lower cost captive options. And so Broadcom is supplying IP to power these AI chips with these big giant internet companies. Now AMD is beating Intel in a market that's declining. The x86 market, you saw recently Intel and AMD, foes getting together to try to prop up the x86 market, keep it alive as possible, as long as possible. That's in their best interest. But AMD is trying to rapidly pivot to AI as fast as it can, and essentially trying to run its x86 playbook that was so successful against Intel, pointing that at NVIDIA, and they're unlikely, in our view, to have the same impact on NVIDIA that they had on Intel, and unless NVIDIA decides to, unless NVIDIA missteps in big ways, as we've seen Intel. And the street, I think, is starting to realize that, putting some pressure on the stock. Qualcomm, not a direct threat to NVIDIA, focus more on mobile and edge, but they will run into NVIDIA at those locations, particularly as we start to see robotics and this distributed edge emerge, and NVIDIA wants to play there. And in Intel, we've talked so much, it's hamstrung by its aspirations of hanging on to the foundry, which we felt all along is just a flawed strategy. It'd be great if they had unlimited capital and unlimited time. They don't. Let's talk about the competitors in more detail. Jeff Bezos is credited with saying, your margin is my opportunity. I'm not sure he actually ever said that, David, but it made good narrative and was apt given Amazon's success in retail. But let's look at the competitive landscape and unpack this a little bit. I'm going to start with Broadcom, David. They supply, as I said, Google, Meta, and ByteDance with key silicon IP in the custom side. Broadcom, we've said, is the #2 AI play in semis. They do really hard stuff. They got great networking. They have industry best in class SerDes, serialization, deserialization, great optics, and a lot of other unique capabilities. And their partnership with Google is key because Google's tensor processing unit, the TPUs, are best in class in our view and definitely competitive to NVIDIA. Do you agree with that, David? What's your take on Broadcom and Google?
Absolutely. That combination, Google is by far the biggest other vendor in this emerging new space. They use it internally to drive all of their applications, and their partnership with Broadcom has been very successful for their TPUs. So that, I think, is a very solid there. And my view, for what it's worth, is that there is an opportunity for Google to actually export that technology more aggressively.
Really, you mean beyond its own captive market?
Yes, if they're going to deal with be a volume player, then that would be, to me, make a lot of sense.
Interesting. All right, we're going to go through the list and riff on each competitor. Let's start with AMD. I mean, as we said, AMD is hurting Intel in a declining x86 market. They've made some moves building out their AI software stack to compete with NVIDIA. They made an acquisition of ZT Systems, again, to compete more effectively as a systems player. Jensen makes a big deal about his systems. They weigh 1.5 tons. They build them and they test them. They optimize them. Then they tear them down and then bring them to the data center and rebuild them. I joke, kind of like the shed that I just bought, but it's a lot more complicated and much heavier. But David, AMD is going to get a piece of that market. Lisa Su, obviously, very capable CEO, but they're probably not going to dominate, or they're very unlikely going to be dominating the market in the way they have x86. What's your take?
I agree with that. I'm a little bit more pessimistic, maybe than you are. And AMD has certainly made huge strides against Intel and in this space. But There's hardware and there's software, and although AMD have a platform software, it's going to be very, very difficult, in my view, for them to compete against the quality of CUDA. We're going to talk about that later. So I'm more pessimistic, but they will get a share, there's no doubt, and they will be a player in the marketplace.
Okay, let's talk about Intel for a moment, and kind of riff on them. We've been, very vocal about our concerns regarding Foundry. I saw a tweet this week from Aaron Levy, who said vertical integration is a real advantage, and he was using Tesla as an example. John Floyer chimed in and said, spot on. I chimed in and said, well, it depends. I certainly believe that when it involves, up the stack hardware and software integration. We saw that with not only Tesla, we certainly see that with Apple, we're seeing that with NVIDIA, and we see it with Oracle. That tight integration of hardware and software confers very clear competitive advantage. And when you think about Intel and Foundry, in concept over time, having that vertical integration, could really be an advantage. But the problem is to catch up to TSM, surpassing Samsung and catch up to TSM is just too expensive these days. And so we saw with AMD when they shed its Foundry, it began to make progress, took some time, but it sort of took those shackles off. We saw IBM under Ginni Rometty basically sold, in quotes, gave, paid Global Foundries a few billion to take its Foundry off its hand, its semiconductor microelectronics division off its hands, and in exchange for supply of advanced semiconductors, which Global Foundries was unable to deliver that advanced technology because of what we've talked about so often, the lack of volume. And that's really what Intel faces right now. The PC market peaked in 2012, 2013, and that's when Intel kind of began to lose its edge to the ARM volumes, ARM wafer volumes. We talked about it endlessly, 10x those of Intel. So our scenario for Intel is that we would like to see Intel shed its Foundry. We would predict that it was going to have to do that this year, and then take the handcuffs off for its designers. We're actually quite optimistic about Intel, its ecosystem, its long-standing partnerships with virtually every company in the industry, its tool sets that it's built out. And we think it would do very well, actually, if it wasn't being dragged down by Foundry. David, your take on all this?
Yes, taking the analogy of Tesla, if you look at the beginning of Ford, for example, it was vertically integrated. But as time went on, it was much cheaper to get the gearboxes or the seats from other people. So the same sort of thing was the case with Intel. At the beginning, they made the market. They had the volumes to be able to create the cheapest chips and keep it going. But the world has changed. And that vertical integration has broken up almost completely. There are only a handful of players that still try and do that. And I agree with you, they should get rid of the Foundry, and they have excellent staff, really good staff and good products. So the product division, I think, would do well. In terms of where they are in the GPU area, that's tougher. They've tried hard on that bit previously, and really they have almost nothing that's of any importance in that space.
Okay, let's come back to that chart, Alex, if you would, and let's talk about AWS and Marvell. You can see them in the middle right there. Marvell supplies AWS with Trainium. Trainium and Inferentia as well, I believe. So we're on Trainium 2, which was announced at reInvent. We're going to talk about this a little bit, but before we do, I want to play a clip from the BG2 pod, which is Brad Gerstner and Bill Gurley. They had Dylan Patel on. Alex, please Play the clip and we'll take a listen.
Amazon, their whole thing at reInvent, if you really talk to them when they announced Trainium 2, and our whole post about it and our analysis of it is like supply chain wise, looks, you squint your eyes, this looks like an Amazon Basics TPU, right? It's decent, right? But it's really cheap, A, and B, it gives you the most HBM capacity per dollar and most HBM memory bandwidth per dollar of any chip on the market. And therefore, it actually makes sense for certain applications to use. And so this is like a real shift. Like, hey, we maybe can't design as well as NVIDIA, but we can put more memory on the package, right?
So David, you heard Dylan Patel, he kind of referred to Trainium as the Amazon Basics of GPUs. Kind of a pejorative, but it's sort of true in a way. Hopefully it's better than Amazon's batteries, which aren't that good. But there's a lot of stuff on Amazon Basics, which I really like. And the point is it's really low cost. And so my scenario on this is basically that Amazon is taking its Graviton playbook that has worked so well relative to x86 and bringing that to GPUs. NVIDIA's operating margins are in the mid 60s. So, Amazon has to pay the NVIDIA tax and certainly doesn't want to for many workloads. My view is that Trainium is going to be appropriate. In talking to some of the folks at AWS at reInvent, Amazon through Trainium 1 has been able to build out its own back-end network. So it is now able to train models without requiring NVIDIA's total end-to-end infrastructure. So it can use its own infrastructure. It's building out its own software tooling. So it's able to do that and get on that curve. So I'm actually optimistic that within the AWS cloud, I think Trainium and Inferentia are going to be a reasonable alternative and capture a fair share of the market relative to NVIDIA. Maybe not as much as Graviton. I know you feel that way, but you're not as optimistic as I am on Trainium and Inferentia. Explain why.
Well, within AWS, within Amazon as a whole, they can tell their developers that they have to use their platform and that's the way it's got to be. And if there are people in the operating world trying to save money on the hardware, etc., that'll be okay for pieces of it. But the drive for NVIDIA will come from the programmers. And I think that will, at the end of the day, the programmers have to be happy. And I think that most organizations, they may try it and see how it goes, but the developers will insist on the native NVIDIA GPUs.
Well, what if Amazon can get the NVIDIA software stack running on its GPUs?
Yeah, but CUDA is itself an operating system, and it's also the compiler. That's not. You can write things to CUDA, but that doesn't mean to say that you can use the CUDA itself and use the instruction set that that NVIDIA has.
All right, let's go back to that chart, Alex, if you would. Let's talk about Qualcomm and Microsoft. Just in the interest of time, let's kind of put those together. We're showing a picture here of Maya, which is Microsoft's, I think it's their inference chip. I mean, I've always felt like Microsoft is well behind on custom silicon. As we know, they were GPU constrained. Satya claims they're no longer GPU constrained, but they were GPU constrained. So they pointed it at things like Bing to try to take a shot at Google's search, because every point that they can take away from Google's search is less money in Google's pocket that they can use to attack Azure. And of course, they're aligned with Qualcomm in their device segment. Qualcomm obviously focused on mobile. Microsoft, clearly major force in the industry. How do you think about them in the context of silicon, David?
Well, Microsoft owns a lot of software. So it's in the position that it can integrate their software stack with their hardware. So they're in a much better position than AWS, for example. So yes, they will take some of the work, for example, within Windows. They will be able to own a fair amount of that AI activity from Windows and use their own technology to interact with it. So, but again, I think that they will cover both bases. They will still use an awful lot of NVIDIA GPUs themselves at the higher end for making the very large models.
Yeah, I mean, it's interesting you say that. I mean, I definitely think Microsoft has a better business model than AWS because it has so much software. Its marginal economics are much better, obviously. But I mean, Amazon's infrastructure is cut above, in my view. But again, from a marginal economic standpoint, software better than hardware. Having said that, I would think that Amazon's got a big lead in custom silicon over Microsoft. Yeah. Not that Microsoft can't hide that deficiency or gap with software margins. It can, but you know, Amazon with Annapurna back in the mid part of last decade has quite a lead. Do you not agree? I want to make sure I understood your comment about Microsoft versus Amazon there. Well,
you made the point yourself. The software margins are 100% for every new copy. So it's volume of software that matters to them much more. Whereas AWS is selling equipment, is selling the hardware. Now with Azure, of course, they will need a lot of NVIDIA GPUs in order to sell to their customers, but they will be able to use for their own workloads a fair amount of their own hardware. And I think the problem of catching up these days, ARM have been very, very good in shortening the cycle time for developing new hardware. They're claiming it's less than a year now from design to tape out. That's unheard of.
This is NVIDIA claiming that. So yeah, let's wrap
well,
up.
No, I was saying ARM was claiming that, but certainly NVIDIA is.
Yeah. So, and that's what everybody's got to keep up with. So in the upper right, you see ARM. We also have on here Grok, which is high-speed inferencing. We got Cerebras, which is the big mega giant wafer. Samba Nova. There's others. We have China on here, which can't be ignored. We're going to talk about them in terms of the threat to Taiwan down the road. Any closing thoughts on, you mentioned ARM, but what about these alternatives like Grok, like Samba Nova, like Cerebras, like China? Where do you see them fitting?
Well, it's just picking one of them, Cerebras. I mean, it's wonderful technology to take a whole wafer and use software to work out what's working and what's not. So that's a very expensive result for them. It's very interesting. I think NVIDIA will be able to use that technology. That technology comes from TSMC. So if it becomes appropriate, then NVIDIA will be able to use that. And NVIDIA are certainly very far ahead in terms of being the leading designer and the leading performance from hardware. It's very much their game.
All right, we got a lot to cover, so we got to move on. At the end of the day, we think the market is so large that NVIDIA's moat is wide and deep. and competition is not really going to be an issue for NVIDIA unless they trip. So we want to dig into that moat and try to connect the dots a bit. We're talking here about tightly integrated hardware and software. It's a platform. It's by far the #1 AI developer platform, which David, you mentioned earlier. And it's got a very broad application reach, horizontal apps, vertical apps, industry apps, emerging fields, autonomous vehicles, robotics, which we saw tons of this at CES. And the mainspring of that AI innovation is really in NVIDIA. And they're very cleverly using open source, and they've got a massive ecosystem. So David, you put together this moat slide. You got FP8s on here, you got tensor cores, you got CUDA NN, you got whole cow. NVIDIA bought Mellanox 4 to 5 years ago to get InfiniBand.
Yeah.
Put it all together. What does this mean?
Yeah, I mean, well, let's start with the whole cow and the hardware. They have a 1-year cycle. They are the best chips by far in terms of performance. The whole cow means that they're using the chips that don't work as well. They're now using them, for example, in the PC GPUs, and that they will be able to use previous versions in the same way. So they will bring a low-cost capabilities right the way across the board.
So whole cow, you're talking about like making hot dogs.
Yes, well, no, you use the whole cow, every part of it. Yes.
Yeah, making hot dogs,
Yeah.
whatever, you name it. Okay, got it. Carry on, please. That's gross.
So, so that's important. They've introduced new capabilities whenever they've had to, like FP8, floating point 8, and floating point 4. They introduced the tensor cores into the GPUs, which gave a 3x performance improvement. The networking with ConnectX, the chips for that are everywhere. Perhaps the most important thing, though, is that base, that CUDA. We talked about it just now. That is the foundation of the connection between the software, the complete set of software for the platform. They're not going up market, they're keeping it as a platform. So a complete platform, and underneath it all is this ability to use CUDA and for it to work out how to schedule, how to run these immensely complicated systems. And that's almost the biggest part of the moat. And that is the area where Microsoft and others have really struggled.
Okay, everybody talks about CUDA. You just talked about CUDA. I've been talking about CUDA. And NVIDIA's been working on CUDA for nearly 2 decades. There is more to the story, but let's dig into the software stack. And so here we're highlighting 6 pieces of that stack. There are more, but these are some of the key ones. CUDA, obviously, NIMS, NeMo, Omniverse, Cosmos, and the developer libraries and tools there on the bottom right. Start with CUDA. It stands for Compute Unified Device Architecture. Everybody talks about it. It's a computing platform. And this platform is optimized for and it enables developers to program AI. So CUDA understands all the GPU resources that it has at its disposal and can optimize, for those. And it's been a pivotal component in establishing the company's dominance in AI and high performance computing. It gives developers an abstraction layer essentially to write programs. You can write, programs in C, C++. You can even write in Fortran. David, remember that? I remember studying Fortran in college.
I do indeed.
So it makes it much easier for developers to build AI algorithms. And the ecosystem adoption is massive. It includes tools like you were talking earlier about, CUDA NN, which includes all the primitives for deep neural networks to exploit deep learning frameworks. These are, when we talk about these, we talk about TensorFlow and PyTorch. So David, you know, the software conversation, as you just said, it's got to start with CUDA, but there's more. Let's talk about NIMS and NeMo. And NIMS stands for NVIDIA Management Interface System, and it's the interface for managing NVIDIA hardware in data centers. It does monitoring, it does diagnostics. So it's not really a platform, it's kind of the management system, if you will. So it does features to control, you know, the workflow. So they're not directly, NIMS aren't part of the developer toolkit like CUDA is. Rather, NIMS, they're supporting capabilities for the infrastructure that makes CUDA and other software effective at scale, because it manages, you know, hardware health, it manages performance, and then you got NeMo, which is an end-to-end platform for developing custom AI models. We heard a lot about this at GTC and last week at CES. It's got a focus, it enables interaction through natural language processing. It includes pre-built modules, pre-trained models and tools. And then the ecosystem, you know, plays with NeMo in the sense that models can be exported to be used in other NVIDIA platforms, like its inference servers. And so this simplifies the transition from development to deployment, David. Anything you would add to NIMS and NeMo? I mean, you talked in detail about CUDA, but throw some more cherries on top of that as well.
Yeah, I think it's more the CUDA, the NIMS is more useful to the programmer, because if you've got a diagnostic problem, these are very complicated systems, it allows those diagnostics to actually happen. So there is more use by the programmers there. And then on the CUDA side, again, from a programmer point of view, it doesn't say you have to use a GPU. You can design programs without GPUs, and then put them in if they're helpful. It's a very, very flexible platform from that point of view. And yeah, this is tremendous support for both operations and the developer.
All right, moving right along, let's talk about Omniverse and Cosmos. Omniverse is an ecosystem for 3D design, enables collaboration. It uses real-time graphics and simulation capabilities. It uses NVIDIA's RTX for rendering. Again, we saw this highly exposed at CES with Jensen's keynote. It leverages CUDA for compute and can integrate with AI models from NeMo or other platforms to do simulations, build virtual worlds. I recommend you watching Jensen's CES keynote. Omniverse was on display big time, and it's really designed to work in conjunction with NVIDIA's hardware. So we're coming back to that notion of tight integration. And he wants to point all this at industry, you know, Industry 4.0. Now Cosmos is new. It's a new innovation that they released last week that simplifies the building and the training of large AI models, obviously deployment, management as well. Well, the deployment as well, not the management. Supporting this notion of a distributed computing environment. The reason why we think Cosmos matters is because it integrates with NVIDIA's hardware and other software, a theme that we keep talking about, their hardware and software stack, which is tightly integrated. So it allows researchers to scale AI model training, you know, very substantially, leveraging all the networking and compute solutions and the other tooling, you know, around distributed learning. So much to learn. We're running out of data, people say. Well, there's a lot of data out there that can still feed these models that not, you know, on the internet. So these two innovations are aimed at transforming industries and building digital twins. And finally, the bottom right here, the libraries and toolkits for developers, something that is critical and often overlooked piece of the stack. NVIDIA has built many, many tools, linear, you know, deep in the weeds here, linear algebra and matrix operations that leverage CUDA and TensorRT, just another example. It's a capability that optimizes deep learning inference. And again, all this works alongside CUDA and NeMo so that you can deploy models into production with a focus on low latency, very high throughput. We're talking machine learning libraries, device drivers, boring stuff, but really, really important. Communications libraries, graphics libraries, the list goes on and on and on. I mean, David, hundreds and hundreds of libraries. I think the number is more than 400 libraries. And so we're talking about a very mature stack, way ahead of anybody else. Anything you'd add to the software stack conversation, Omniverse, Cosmos, and the libraries discussion?
It is an incredible stack, and they're so well integrated, and it provides that basis for operations and programmers to put in any of the systems they require. I myself worked on boats that made bangs and looked for oil. So Fourier transforms, real-time Fourier transforms would be something that would have been fantastic if we could do that on the boat and not have to send all the tapes back to the mainframes or the large system.
Those are the days. All right. Okay, let's take it. Go ahead. Carry on, please.
No. It's just it's NVIDIA's software advantage, and in many ways, this is the heart of their moat. Hardware other people could compete with. This moat makes it very difficult.
Well, I think it's worth pointing out. I mean, we watched. You talking about we were going back to the mainframe days. We watched IBM inadvertently hand its monopoly to Intel and Microsoft, respectively, with Intel the microprocessors, Microsoft with the operating system, and then ultimately the applications. And Wintel became a 20+ year monopoly. And we see in many ways NVIDIA as both win and tell, or tell and win. It's not just a hardware company, not just a software company, but both. Obviously there are differences, but that's the potential type of dominance that we see coming down the pipe. All right, but let's take a quick detour and talk about AIPCs. We've got a chart here from ETR. We love this two-dimensional chart. It basically shows net score on the vertical axis, which is a measure of spending momentum and an overlap in a data set of about 1,835 IT decision makers. This is part of ETS's or ETR's TSIS survey. In January, it'll be released. This is preliminary data, so it'll be released later on this month. But you can see on the horizontal axis, Dell is number one. You see that shared N, that insert, that slide on the insert. The net score and the N are how it's plotted. So the N, this is sorted by net score or spending momentum. The N, you can see Dell is 543, Dell laptops. So they're the most prominent in the market. You see Apple, right there as well. Both of them have pretty prominent net scores. Anything over 40% is in the stratosphere. So mid-30s, low to mid-30s is very strong. And you can see the others, HP, Lenovo, you got the iPad in there, Logitech. I didn't know Logitech made these things, but yeah, they do. Dell tablets, et cetera, down the line. But really, we saw Dell introduce a number of AI PCs at CES. We saw Jensen introduce basically a laptop capability that he's going to sell to OEMs. I believe Dell is working with Qualcomm and AMD and I think Intel, and I think it's built at an abstraction layer to make it simpler for developers. I would expect, David, that a company like Dell is going to be using NVIDIA at some point. Who knows? Yeah. NVIDIA could potentially dominate. They showed some pretty impressive pricing. But what's your take on the AI PC piece of the world?
Again, to me, it comes down to, again, the programmers. They want to be able to provide the tools so that anybody can get through to the CUDA and all the other software. And that software is But that's why they are dabbling in this whole area. And using their GPU, which they've had for a long time, and providing a desktop and GPUs that go fit into laptops and desktops, etc. Providing these GPUs and providing them with both the capability of running graphics and doing the work for developing as well is a very sound strategy. Obviously, Apple has an edge in terms of performance at the moment with the M4 chips that they have there. Those are done very, very well indeed. But in terms of this new type of workload, I think that NVIDIA is going to partner with a lot of these people. It's going to partner with Microsoft on Windows. It's going to partner with everybody they can to make sure that developers can take advantage of the CUDA and the rest of it for developing AI systems.
Yeah, it was interesting. Jensen mentioned Windows 95 as the most popular developer platform and how they're going to integrate there. Somebody in the audience said, "What about Linux?" And he goes, "Linux is great." And so,
well, the desktop machine runs Linux,
right?
Yeah.
And so, but let me ask you, what's the role of the NPU? Apple's been shipping NPUs, neural processing units, for many years, although I'm not sure how much it has meant to the user, although it's certainly helped them reduce power and elongate the battery life. Dell talks extensively about NPUs. Michael Dell makes a point of highlighting that it's a new component within their PCs. Others, I know I've talked to Bob O'Donnell a lot. He's saying, yeah, but a lot of times the NPU is sitting idle on these AI PCs, and the CPU and the GPU are sucking up all the resources. And that's in talking to you in large part because they haven't been optimized yet. That's the developer piece that you're talking about. What's the role of the NPU, the neural processing unit?
Well, it's got a very big role. I mean, it's a role that, for example, Tesla has used very extensively for analyzing video inputs. And Apple were the first people to start down the road of this highly parallel technologies. They put the NPU, the processors, and the GPU under the same SRAM storage, which meant all of this could work together very, very well indeed. Other architectures from Qualcomm and others and AMD have used lots of chips and tried to connect them together, which is not nearly as effective as the Apple construct. There are the advantages of NPUs is that they're much more effective from both a cost point of view and space on the chip, and from a performance point of view for certain types of workloads.
Who's they? Who's they in that statement? You're talking about Apple, or you're talking about the alternatives?
I'm talking, can you just remind me of what I...
Yeah, you just said they are more cost effective. What did you mean? Do you mean?
NPUs are more...
NPUs are more... Yeah, so to the extent...
Can be for certain workloads.
To the extent that you can exploit them, they'll be much more cost effective. So Apple's sort of been on that curve for a while. Okay.
For a while, and Qualcomm have and Microsoft have used the NPU to define an AI PC. Coming back to NVIDIA, their GPU is much more powerful than the NPUs and GPUs in, for example, Apple or any of them. So these systems doing the work for AI applications and graphics, etc., they're going to be very, very interesting to a lot of people.
Yeah, but don't you need a windmill to be hooked up to your laptop to be able to power the thing? I mean, again, well, they're more powerful, but they're also more energy consumptive, aren't they?
Yeah, but remember we talked about they're using the biggest chips in the, in the data center, and then these cast-offs they're going to put into they cut down the power a huge amount and
Whole
put
cow,
those
whole cow. Okay.
whole
Hey,
cow.
I gotta, sorry to interrupt you. I gotta move on here. Let's look at the market for data centers. This is some great work and how it's shifting right in front of us. It's quite dramatic. Here's a forecast that David Floyer put together. This is the entire data center market. So it includes, servers and networking and storage, the whole kit and caboodle from 2019 to 2035. So this is the end market spend. It's astounding, actually. We're in a 10-year super cycle of data center growth catalyzed by AI. Some don't like that term super cycle, but it's really appropriate in our view. So the key takeaways here, again, this is all data center spend. It doesn't include the laptop spend. It doesn't include the edge, I presume.
No,
it does include cloud, correct?
it does include cloud,
Yeah, so,
and it does include power supplies and power and cooling, etc.
so this is the data center TAM, if you will. It gets to $1 trillion by 2032, gets to 1.7 trillion by 2035. The 10-year data center CAGR is 15% when you go from 24 out. And then the 10-year CAGR for extreme parallel processing is 23%. So we're talking massive growth, massive market. This is a market that was growing at single digits and even shrinking, prior to ChatGPT when we hit COVID. And then the extreme parallel processing goes from 8% of the market in 2020 to nearly 90% by the end of this decade, with NVIDIA capturing about 25% of that data center spend today. And we think that holds up through the forecast period for the most part as the AI workloads take over from the traditional workloads. So if you go back to that chart for a second, Alex, I mean, just look at the orange is the traditional processing that's just getting squeezed. Now in 2021, we put forth a similar slide. It was too conservative, frankly. We probably had half the market, going to the blue, which is the extreme parallel processing. But you can just see the forecast here. And, people might say it doesn't happen that fast, but David, you would disagree. What are your thoughts?
Yes. It really comes down to the applications that can be made from this technology. And we started now with the chat GPTs, which are improving individual productivity. We're going to see agentic models aiding companies, helping to improve the processes within companies. We're going to see those agentic models to some extent combining together, though that may be a little more difficult than it sounds. But the long-term one, and the one where the most bang for the buck is going to come, is when they can put together the simulation of the real world and be able to develop robotics, which will completely automate business processes. The other two will improve it, but the automation will have a dramatic effect. So automation, robots in the house, etc. And that's the last part of that. So,
well, that's not on this chart. That's not on this chart, right? That's not included. I mean, there's some back-end support for that, but now you're talking about a $50 trillion TAM, which is the entire GDP
Yes.
of the world.
Yes, yes,
Right?
yes.
So,
I'm sorry. This is the data center part of that
yeah.
that marketplace. I have not included robots and other things. What I'm saying is the return on investment from developing the applications that will run using these robots and using all of the other components is just the data, the business case is just overwhelming. So that's the reason I believe that spend is going to completely change. And, you know, we're seeing the same sort of increase in spend as we saw when the PCs came in. You know, they went up in volume, and the amount of compute, amount of time that people spend was absolutely enormous. And the same is going to happen with you know, to a whole larger extent than that. This is the biggest single change.
And the difference is that the microprocessor-based revolution, it didn't have the infrastructure and the software, not that this does, but you saw a dramatic shift in price performance, which actually decimated the legacy mainframe and mini computer business, and all the spending shifted and actually compressed. It acted as a compression force on the overall market. This seems to be different because essentially you're talking about it. It's kind of cloud-like in a way, but on steroids, where you're seeing a shift from traditional general purpose computing to this extreme parallel processing computing or accelerated computing, which is actually more expensive in a lot of ways. And so it actually is a tailwind potentially. We've got to move on, but we've identified 5 key risk areas in order of degree of importance to this scenario, what could go wrong kind of thing. There are many more, but we see these as the big ones. We'll take them one at a time. I'll run through them and then we can chat on it. You know, reliance on TSMC and supply chain disruption, the threat of China invading or taking over Taiwan, getting control of TSM and the foundries, the time it's going to take for the US and European foundries to get to where TSM is in Taiwan is quite elongated. And so that gives a pretty big window for that risk. And that's why we put it first. Look, AI might fail. The next one, AI might fail to deliver on its promises and the economy tanks. And that sort of, you know, puts a pall on the AI trade and you know, concerns about NVIDIA. We've seen the stock has been very volatile over the years, whether it's been gaming to crypto and the crypto crashes and, you know, AI. At some point, you know, will the air pop out of this bubble? You know, it's not unlikely that there's going to be some bumps in the road. The trees don't grow to the moon, as they say. So that could be, you know, risk to the scenario. Open source alternatives to NVIDIA's software stack. A lot of people are working on it. We showed the slide earlier. You know, people love NVIDIA, but they don't love paying, you know, 65% operating margin, you know, to the company. You know, NVIDIA is getting its pound of flesh. Antitrust, big deal. Even though Lena Khan is going, antitrust looms large, and regulation. We'll see how the new administration responds, and the new administration after this one. Who knows? You know, J.D. Vance is kind of a conservative, they call him. So he's in line for the future, as are others. So we'll see what happens there with regulation. There's a big tech lash that continues. And then alternative approaches, quantum computing. Jensen said quantum computing's, I think he said it's like 2 decades away. Arvind Krishna said it's more like, you know, 4 to 10 years, you know, inside a decade. So, but that looms. And then low-cost competition. We cited a number of them before. David, we'll give you last word here.
Yes, I think your point about the backlash of AI and the automation and the loss of jobs is something that is potentially a very real threat to the scenario, and it will have a major this whole capability is going to have a major impact on society.
Yeah, well, look at the number one business case for AI is reduction in the amount of labor required to do stuff. So there's very likely going to be an impact on labor. We know that, and there's probably going to be a trough before it goes up again. I'm a believer that it will go up, but okay, David, hey, thank you so much for the collaboration. Awesome, as always. We got to leave it there. Really appreciate your time.
Fantastic, thanks.
All right, and thanks to Alex Meyerson and Ken Schiffman on production and on our podcast, and Kristen Martin and Cheryl Knight helped get the word out on social media and in our newsletters, and Rob Hof for all his great work as our EIC over at SiliconANGLE.com and the whole team over there. Thank you. Remember, all these episodes are available as podcasts wherever you listen. Just search Breaking Analysis Podcast. I publish each week on thecuberesearch.com and SiliconANGLE.com. You can email me at david.vellante@siliconangle.com or DM me at @dvellante. Comment on our LinkedIn post and check out etr.ai for the best survey data in the enterprise tech business. This is Dave Vellante for David Floyer and theCUBE Research Insights, powered by ETR. Thanks for watching, everybody, and we'll see you next time on Breaking Analysis.